So in this one, ladies and gentlemen, to do the first or second derivative test, we obviously need to identify the first derivative to identify what the critical values are. Correct? So just remember, anytime you have a square root or any root, you can raise that to the 1/2 power, right? So what I automatically immediately see on this problem, if I'm going to take the first derivative, I'm going to need to use the chain rule. So I'm going to bring down the 1/2 in front. X squared plus 1, I'm going to subtract, so that's going to be a negative 1/2. However, I have to apply the chain rule here, so I have to multiply by the derivative of the inside, which is going to give me 2x. That can then be simplified to 2x over 2 times x squared plus 1, where those divide out. So we have h of x equals x over x squared plus 1. Square roots. Oh, I forgot to write that in there, didn't I? OK. Now, I need to find the critical values. So I need to go and take my first derivative and set it equal to 0. However, ladies and gentlemen, remember, whenever you have a rational expression equal to 0, basically what you do, I'm not going to show my work here, but basically what you do is multiply x squared plus 1 to raise to the 1/2, or the square root, on both sides. And you're going to get a critical value at x equals 0. Another simplistic way just to think about it is setting the numerator equal to 0 when you have an expression that looks like that. Is everybody OK with on this? Yes? No? Huh? What? Set your numerator equal to 0. Because in reality, you have to get this off the denominator, right? So what are you going to multiply by? X squared plus 1 to the 1/2. X squared plus 1 to the 1/2. Well, that goes to 0, and that goes to 1. So you're just left with x equals 0. All right. So now we need to determine the second derivative, unfortunately. So determining the second derivative, I'm going to need to use the quotient rule. Thank you, Mary Kat. I appreciate that. Yep. These are under the radicals. It's under a radical. Yeah, because it's not those that they don't have the, if you were to, well, first of all, you can't, they don't have this, they have the same base, but they don't have the same power, and you can't distribute that 1/2 across addition. So it kind of ruins everything. So we're just going to have to fight our way through the quotient rule. It is the same as the first derivative, right? You're right. Thank you. I should save myself some time. All right. Then, now all we need to do is go ahead and find h double prime of 0. And so basically, you're plugging in 0 into each and every one of these, Edward. And when I plug that in there, I get 1 minus 0 over 1, which equals 1. So therefore, I can say h double prime of 0 is greater than 1. I'm sorry. Yeah, it's greater than 0. So by the second derivative test, since h double prime of 0 is greater than 0, h of x has a relative minimum at x equals 0. OK?